In this lesson, we're going to re-examine the sine law, go over some things we learned about in grade 10, but also add some new interesting situations to the sine law. So we like the sine law for situations involving non-right angle triangles when we can't use SOHCAHTOA. But in order to do the sine law, we need to know a corresponding pair of angle and side, in particular the angle and the side across from it. Quick reminders, capital letters are used for angles, and the side across from it are the corresponding sides. In order to use the sine law, we need to know that pair. I need to be able to make a fraction out of it. And then I need some other pair, and I need to know one of the two things. So I make a second fraction, and we can cross multiply and solve this. There really are only two situations we can use the sine law for. So we look at the first example. I have an angle, and I know its corresponding side. So I can write in the sine of 70 goes to 17. The fact that I know that pair means I can use the sine law. 50 is going to go with x. Make sure it's the sine of the angle and the x. We're going to cross multiply. So x times sine 70 is x sine 70, and 17, equals 17 times the sine of 50. I want to get x by itself, so I'm going to isolate it by dividing out the sine 70. I can punch that all into my calculator the way it is, and we end up with 13.86 if we do it correctly. Okay, so that's situation one, finding an unknown side. Situation two, again, I have a pair. I know they go together. But in this case, I am missing an angle that goes with the corresponding side. So this is situation two because I have the unknown angle. We're going to approach in the same way though. 37 times the sine of 32. And I'm going to stop here. I'm not going to multiply 43 times sine x. I'm going to leave the 43 where it is, on the bottom of the fraction, because that way I have x isolated. The only problem is it has that sign in front of it. To get rid of the sign to find an angle, we have to take an inverse. Now I can figure out the division part first. I can actually do 37 sine 32 divided by 43, and then take the inverse of it. Or I can use a bracket function in my calculator and just type it all in the way it looks. Either way, I should end up with 27.13 degrees. Okay, those are the two basic sine questions we can do, an unknown side or an unknown angle. As long as you have a pair, sine law works great. Okay, but we're going to look at a situation where we might run into some difficulties with the sine law. So in this problem, we have Albert and Bell, and they're studying some thunderclouds. The team is about to launch a weather balloon into an active part of the cloud. Albert's rope is 7.8 meters long, makes an angle of 36 to the ground. Bell's 5.9 meters long. How far apart are they? Most people, when they jump into this question, say, well, I got Albert, and I got Bell, and the balloon's up in the clouds, and we have our angles, and we got our triangle, and we say his rope is 7.8 meters, hers is 5.9 meters, 36 with the ground. That's how most people jump into this question. The problem is, nobody ever said that Albert and Bell are on opposite side of the balloons. Is it not possible that if that where the balloon is, and Albert's here, that Bell could be standing closer to the balloon, but on the same side as Albert? So again, we still have 36. We still have 5.9 meters. We still have 7.8 meters. But she's standing in a completely different position. So if I want to know how far apart they are, I could have x or y, and they'll be completely different values. And we call this the ambiguous case, when we don't know which triangle is formed. Okay, we can solve these things in basically the same way. The problem is we've got two different solutions. Okay, so we're going to look at those two solutions, both at the same time. And we'll do solution one here. We got sine law. We got a pair of things that go together. So the sine of 36 goes to 5.9. And the sine of, I need to figure out what this angle is down here. Okay, we'll call this one, let's call this letter B, okay, because that's the angle. So the sine of b goes with 7.8. We can do our good cross multiplying. So 7.8 times the sine of 36, 5.9 sine b. We can take the inverse of that big mess of numbers, 78 sine 36 over 5.9. And if I do that, I got an answer of 7 point, oh no, that's the wrong one, 51 degrees. Okay, so I know my answer is 51 degrees for the angle. Now why did I have to find that angle? Well, if I know this is 51, I can now figure what the triangle adds up to, 180. So tell me that the top angle has to be 78 degrees. Now that I have the angle, I can find its corresponding opposite side. So it's a two-step problem, this one. Okay. Sine 36 goes with our 5.9. The angle at the top of the triangle we just figured out was sine 78. It's going to go with the x that we want. And I got to do my cross multiply and solve. So x9, 5.9 sine, divide out. And we get an answer of 7.43. That's if they're on opposite sides of the balloon. But we said they might be on the same side of the balloon. So if we look at the second example, the second half of this, they again have the same situation. If I want to find y, I need to know the angle at the top. To find the angle at the top, I've got to find angle B first. So I can match up sine 36 with 5.9 equals sine B with 7.8. But wait a second, didn't we already solve that problem? That kind of looks exactly like this. So we have to think for a second here that obviously the picture is different, right? The picture looks totally different, but we're going to end up with the same answer. If we get the same answer for B, won't that give us the same answer down for Y as we did for X? So we have to imagine this problem as actually being a triangle inside a triangle. We said in the first example that Bell could be standing on the right side, or Bell could be standing on the left side. So when we solve this, the answer we got for B being 51 is fantastic. This answer right here is great. That's what B is. But B is here, which means that B is here. This is an isosceles triangle, 5.9 meters, because we don't know which side they're standing on. Which means if I want to solve for the angle on the inside, I have to take 180 and subtract the B, we have a straight line there, to get 129. Which means if they're on the same side, the angle up here, again I got to take 180 and subtract my triangle, which we now know is 36 and 129, to get an answer of 15 degrees. Now I can solve for y. Okay, how am I going to do that? I'm going to say the sine 36 goes with 5.9. I'm using 36 with my 5.9. And I'm also using the sine of 15 going with the y. Okay. But to get that, I had to recognize this is the fact that I had an isosceles triangle, and I don't know which side B is on, the bell is on. So when I solved it, it's always giving me this outside angle. Sine law assumes that you're finding this kind of triangle. Sometimes you have to think about the fact you're finding the other kind of triangle. So cross multiply and solve this. It's the same question we did a second ago now. Y sine 36, 5.9 sine 15. And we'll get y by itself. and hopefully you got 2.60 meters. So if they're on opposite sides, obviously they're further apart, but if they're on the same side, they're pretty close together. How do we recognize we have that situation? Okay, that's the tricky part, right? How do I know? Well, there's no rule for us. If we know two sides and the non-included angle, so I know a side, but I don't know the angle between them. I don't know that. Well, then we have this situation. Okay, so that happened in our previous one. In the previous example, we had Albert, we had Bell, and we knew the angle over here, this one. But I didn't know the angle between them in the middle there. That caused ourselves some confusion. So if we come across that situation, we have a non-unique solution. There might be two possible answers. To figure that out, what you can do is calculate the height of the triangle. The height of the triangle if we find the height of our triangle, and if we try and draw pictures always the same way, it makes life a little bit easier, we can actually determine if we have one triangle, two triangles, or if a triangle is not even possible to make. And the way we do that is we take our b times the sine of a. That is the angle that you know and the side beside it. Okay, so if you were to draw it differently, you can do that, but make sure it's the side and then the sine of the angle beside it. It will always give you the height of your triangle. And the situations we're going to come across are three. Number one, you end up with a triangle that can't actually be calculated. So that is, you have an angle that you've been told, and let's say it's 30, and you're told this is, I don't know, 18, and the other side here is only like 6. So if I try and calculate the height of that, and I take my 18 times the sine of 30, well, the height of this triangle is actually 9. So if I were to draw that line straight down, it has to be 9. But the side I've been given only comes down as far as 6. Well, that's not possible to make a triangle then. So that's situation number one. If your extra side is shorter than the height. Situation number two is that extra side, the far side, is actually the height itself. In other words, when you calculate the height, same numbers, let's use those, make life very easier. When I calculate it, it turns out that the extra side is the height. And then the third case, the weird one, is, again, we'll try that 30 and our 18, and the extra side, the side over here, is bigger than 9, so it's more than the height, but it's not quite as big as the side we're given. Well, that situation means I can create a triangle, 12 long, but the triangle might actually be inside the other triangle. And then we've got our isosceles situation. Okay? In that case, we have to deal with the two triangles. So we'll go through some. And I know it can be a little confusing, so we're going to try some. So determine the number of possible triangles can be drawn with the given measures, then find the measures of the other angles. So triangle x, y, z. I'm going to try and draw them the same way so it makes my life easier. Here's x. My angle is 29.3. I know the x side is on the other side, but I don't know if it's big enough to hit the triangle. My second side is 20.5. So let's do our calculation of height. My height is the side times the sine of our given angle. If I punch that into my calculator, I end up with a number like 10.03. So the height of this triangle is 10.03. Is my third side, this side, long enough to make a triangle? Is it more than the height? Oh, for sure it is. So it can come down and finish it off. Is it more than the first side I was given? Yeah, no. So it might be able to fit inside the triangle. This is the double triangle situation. So if I want to find the angles, I know I can match up 29.3 and 12.8. I know I can match up y with 20.5 And now we can cross multiply and solve this. We're going to do that right now. We'll get 20.5 sine 29.3, 12.8 equals sine of y. Okay, I'm going to take the inverse of all that big long mess, and I get an answer of 51.6. Okay. So if I know that angle, I'm going to label the triangle now, all the other parts, all the other angles, okay? So we just figured out that y was 51.6. That's this one. But because it's isosceles, it's also this one. If I use the idea of 180 minus, it's a straight line, I can figure out that angle is 128.4. I can figure out the angle at the top of the triangle. That's 76.8. And I can find the little small angle in here. That's 22.3. Just by knowing what triangles add up to. Okay. Try the second example and see if you guys can figure it out. Okay, triangle UVW. Okay, so W, my angle in the corner, 38.7. My side is 25, the opposite one is 10. Find my height. My height is 25 times the sine of 38.7. If I try that, I end up with 15.63, which tells me my height all the way down has to be 15.63 to make a triangle. But the problem is, this one comes down as far as 10. That means no triangles are possible. I can't get that side to actually continue down and actually make a triangle. It's not even as long as 15.63. Okay, so there's our sine law. So the math part's the same. The problem is now, how many triangles do we have? Okay, try the homework.